with physical and analytical chemistry to detect, determine, or quantify the molecular or structural composition of a sample. Since light holds information about the materials found in objects, spectroscopes can be used to separate visible white light into a pattern of wavelengths that represent what the object absorbs, emits, or reflects. A spectroscope takes incoming light and shines it through a prism. The prism refracts the white light and splits it into various colors. The colorful lights bounce off beams in different directions. As a result, the viewer is able to see the colors in a single band as absorption lights.
The various colors are different wavelengths of light. The wavelength is used to determine the frequency of the light wave and the distance the wave can travel. The usefulness of the spectroscope comes with considering the types of light emitted by different elements. Each element, when caused to emit light, emits a signature spectrum, a set of wavelengths specific to that element alone. The spectroscope has been crucial in determining the types and concentrations of elements present in the solar system and the whole universe.
The spectroscope is simply a box with a slit at one end to let in light and a light separating device at the other end. The light separating portion of the device, called a transmission diffraction grating, contains a mirror and a surface with a series of angled edges, or grating. The angle and the spectrum of the incoming light determine how the rays bounce or diffract off the grating, separating them into individual observable wavelengths. Before lab, make sure you follow all safety precautions. This includes keeping your goggles on. The goggles reduce the transmission of UV radiation that is produced by various light sources. Make sure any loose hair, clothing, or jewelry is pulled back. Wearing gloves at all times when handling chemicals. Clear the space to be free of lab notebooks, laptops, or cords. First, to ensure your spectroscope is properly adjusted, set up a white light source. Dim the lights of the room so that the light patterns may be seen. The room, however, should be lighted enough for the energy scale to be seen. Hold the spectroscope with the eyepiece towards you and the small square opening at the other end close to the light source. If you look into the eyepiece, you should see a small vertical rectangular slit. Without moving the spectroscope, look to the left of the slit and you should see an illuminated scale like this one. If the scale appears to the right, you have the spectroscope upside down. While still looking at the scale, carefully rotate the eyepiece until you see a continuous spectrum within the scale.